Thank you for choosing to use the Professional Learning Community Guide for Improving Mathematical Problem Solving for Grades 4 to 8 produced by IES. This practice guide, we hope, will help you move forward in thinking about how to make more robust mathematical connections for students as they, in turn, learn to empower themselves and feel confident about approaching mathematical problems. This practice guide, in conjunction with the PLC, focuses on 5 different recommendations. In the PLC resource that you're using, we're going to actually emphasize 3 of those. The first recommendation that we focused on is recommendation 3, teaching students to use multiple representations. Using multiple representations in your mathematical class helps students to make connections across concepts and skills as they learn how to model those in different ways. The multiple representations should focus on a physical activity, a diagrammatic representation, and a symbolic one, all done concurrently. Using them in a concurrent fashion allows students to create what we call a mental residue. A mental residue is that picture of the task that they did that remains behind as they move forward. These multiple representations can include tables, charts, strip diagrams, number lines, schema, and others that might be appropriate for the mathematical idea that you're representing. It's really important when you're using multiple representations to make sure that the representation itself accurately models the mathematical idea that you're focusing on. It's also important when you're working with multiple representations that the multiple representations are consistent. That is, when you have a particular problem type, allowing students to see how that representation models the problem and models the structure of the problem helps them to form and build a toolkit or a toolbox where they can pull these representations and use them when they encounter another problem with a similar structure. Recommendation 4 focuses on exposing students to multiple problem-solving strategies. When we talk about problem-solving strategies, we're talking about problems that might include translating that problem into an equation, but also, and equally if not more importantly, problems that can be solved in unique and much more novel ways than an equation. It's important that students have an opportunity to experience a wide variety of these problems so that they gain not only the confidence to attack a problem, but also build consistent strategies that can be used to apply to a problem. It's important that they see problems that can be solved in multiple ways, that may have multiple solutions, or even no solution at all. Those are the kinds of problems that help them to build that opportunity to engage in a problem-solving task, even when they've had no experience with a problem, but they're eager to engage in it because they have strategies they can use. Throughout all of these, recommendation 5 is a consistent player. Recommendation 5 is about students articulating ways in which they're thinking about the problem, any problem, and a concept or skill in general, and applying it to mathematical notation. You'll notice as you go through the PLC guide that students should be given opportunities to model in different ways and then explain their thinking about that. In addition, we would hope that teachers would also do a think aloud where they're working with students and be able to articulate their selection of a particular strategy or representation so that it embodies the mathematical thinking that parallels that particular choice.